From now on, all the upcoming videos of this series will be available early for the members of the channel. That means that if you have the membership, you will get access to the videos before they will be released to the public. It's a great way to stay ahead and support the channel and dive into the content as soon as it's ready. Thank you so much for all the support, and as always, happy coding.
Welcome back to my YouTube channel, and this is going to be the next part of our CMP series. In this video, once again, we will be covering the Kotlin Essentials, and in this video, I am going to cover the null safety, which is one of the major feature of Kotlin. So, what is null safety, or what do we mean by null safety? um, you take it as that one of the most occurring crash in programming is null pointer exception. uh, like if I try to explain what I mean over here is that, let's say I'm working in Java, and I'm creating a variable. Like most of the time, what we used to do is that we'll be creating, let's say, int a is equal a, like this. Okay, now I create this, and most of the, like, it's like very common thing among developer that define a variable, but they don't assign a value into it because they think that will add it later on. And then at some point they miss that, before like assigning they use it or something like that. So so it causes a crash, and when it crashes, this means that your app completely shuts down, and then you have to restart. So it is considered to be the $1 billion mistake, the null pointer exception. And when it comes to Kotlin, Kotlin has this null safety approach, which is one of its major feature. And by using this, you can avoid null pointer exception in your system. So in this video, we will be covering how null pointer, like how does it save it, like in normal programming, what's the difference between Java and how it is like making sure that it never happens, in Kotlin, or like it happens but like in a very reduced manner. So let's just get started. So the first thing that I would like to let you know, guys, is that remember these things. So one is this, okay? Then there should be this one, then there should be this one, then there should be, what else, this sign. What else do we are yes, this one. So, okay, so these are some of the operators that you need to remember. Okay, and they are the one that we'll be using a lot in Kotlin. And in this video, what I'm gonna do is that I'm gonna share or explain how and when do we use them and what's the benefit of using them. So we'll try to cover some sort of this implementation for these. So I'll start with this first one, which is called as safe call operator. Okay, so what exactly the safe call operator means? So let's say in Kotlin, what happens is that whenever you create a variable by default, let's say I create a variable var name as string, this is considered to be non-null. Like it's for sure, it's done deal. Okay, and when I say non-null, what I mean is that, let's say if I assign a value into this for Khan, let's say, okay, and later on I try to update the name to null. So what I'm trying to do over here is that I created a variable, I initialized it with some value, but now later on I want to change that value to null. And like I said, in Kotlin, when you define a variable by default, even if I remove this as well, by if I define some variable by default, what it basically set it as a non-null variable. Like in Java, it's different, but in Kotlin, this is the rule. So let's say there are cases when you have nullable variable, and you want some sort of values when during your implementation of any sort of feature, to set the value as null. So what do we do to set that as null? What we need to do is that we need to define the data type. Along with that, we also need to add this question mark. This question mark makes is kind of either nullable, it makes it a nullable, which means that the system or the developer can now set a value as null into this. And now let's say if I print the name, you will see that this is how it does. let's print the name first before setting it to null, and then later on as well. Okay, now let me run this. Now when you run this, you will see that it's first printing. Okay, sorry, it's a mistake from my end. We should be using println so that it prints into the next line. Now you can see that we have the first Furkan, this one, and then we have null, right? Now this was something to tell you that how you can create nullable variables. Most of the time, almost like I would say 70-80% of the time, the variables that you create are nullable, because the data can be different, and you need to allow the system to be nullable so that you can handle it properly. But in this that case, it comes with some issues. For example, let's say uh, if we have something like this, and we, rather than having setting it as Furkan, I'm setting it as null. And um, now let's say when we try to access this name, let's say we want to print ln the name dot length. Okay, so when we try to print the name dot length, if it's a null, the Kotlin, what Kotlin does is that Kotlin basically restrict us with at the compile time. Like, it won't even compile if I try to run this. Let's say I try to run this, you can see it's saying that only safe operators or non-null asserted operators are allowed in this specific line. The reason is that because I am using a question mark. And now if I take out the question mark and set it as this, now it will run. And the reason it's running, because I make it as non-null. Like, if I make it a non-null nullable and run it, it will always complain. So basically, if there is any variable that is nullable, that has this question mark by end, you can access that by two ways. One is the question mark. This is a safe operator, safe call operator that we discussed. And what it does is that it says that if the name is not null, like, it the question mark checks if it's a null or not. If it's a null, what it will do is that it will call this function, the next function that comes after this dot length. If not, it won't, and it will, you can use it directly. Now when I run this time it won't crash. Instead, oh sorry, I need to set it to null. Okay, now when I do that, you will see that it will return, rather than returning the length, it is what's it doing is that it's printing the null. Okay, now um what if I want to have some sort of default value, or saying that no, that the name is invalid, or the string that you input has invalid, because the null is not anything. So for that, what we do is that we use Elvis operator. Elvis operator is that, let's say you're using some sort of a nullable variable, and you have added this kind of implementation with safe call operator, where you want to do some sort of maybe call a method, or maybe access a variable, or whatever you want to do. But if that value is null, and you want to have an else kind of situation, that if it's a null, fine. If it's, oh sorry, if it's not null, fine. If it's null, then maybe have some sort of default implementation for that. So let's, for that, what I'm going to do is that I'm going to add that else operator. This was the second one, else operator. And what it will do is that it will help me setting like defining a default value for this. So we can say no value entered, for example. Now let me run this. When you run this, you will see that it will print no value entered. But as soon as I add a name into this, what it will do is that it will print the length of that variable, of that string. So basically, that's the difference between the safe call operator and the Elvis operator. Right, now the third one is the so basically I'm skipping this one and I'm using this one. This is basically non-null assertion. The non-null assertion mean is that you tell the system that I know that this is a nullable variable, but I am super sure that at this specific point the value is not going to be null. So if you are sure about these kind of scenario, over there they use this like this. And then if you added this means that this name, like, we know that it's nullable, but since we added this means that it will not be using or not be requiring the Elvis operator, so you can get rid of that Elvis operator. Now if I run this, you will see that it works. It prints that detail for me. But let's say at some point I want to set it as null, and now this is a scenario, you have this nullable string that I set it manually as null, but I'm telling the system that no, this variable is not null, and just try to access this value or this specific um, uh, property from that specific variable. So now when I run this, it will crash and it will say the null pointer exception. So, and the reason it basically gave me a null pointer exception is because I use this use this operator telling the system that this is a non-null thing, and uh, this is one of the operator that is there in the system, but it's like not recommended at all to be used like this way. It can be used like in some cases where you are super sure that this value that's coming from the maybe into a function or into a class or anywhere, when you're sure that okay, this is not going to be null, only at that point you can use it. Or if you are not sure, always use the non null operator, or and then using a non null will help you out. Now I'm going to show you something more interesting. So now you saw that the uh, safe call operator, saw the Elvis operator, you saw the non null assertive assertive operator as well, right? Now I'm going to show you that there can be cases where you want to execute a specific functionality based on the like based on the nullability of the variable. So let's say if you want, that this name can be nullable, but you want to be super sure that a specific certain code, a certain chunk of code only runs when the value is non-null. So for that case, what you can do is that you can use the dot let operator. And what does that mean is that for that you can say name dot question mark dot let, and this dot let mean is that it will check if the name is not null, the question mark, save call operator. It will check that, and only if it's not null, the internal chunk of code will be executed. And now over here you can println the name, and you can access the value of the let like a non-nullable value as it as well inside this. Now when I run this, it will be executing because I've set the furkan. But if I pass null, you will see that it won't print anything. You didn't, it didn't print anything. Or you can just println one more thing over here is just basically end. So we know. So now you can see now it just executed with end. But if I change this to Furkan and print it, you will see that it will first print Furkan and then end. And that is how basically we use the let along with the safe call operator, right? There's one more thing is basically the Kotlin casting. I'm not sure if we have discussed the casting, but the casting. What does the casting mean? Is that we basically covered it slightly um, in the conditionals. So I'm going to create a one function and call that is print type. If you remember this specific function, and I said this that item as any, I'm going to question mark that, right? And now over here inside this, I'm going to say when, and I'm going to pass that item into it. Okay. Now over here, what I'm going to do is that I'm going to say if it's string, let's say if it's a string, I'm going to append something into it. So I'm going to do some stuff and we'll be using it as uh, item as string. you know we casted it into string, and then we say that add. Wow, that's one thing that I did. if it's an integer if it's an integer, what I'm going to do is that I'm going to cast this specific thing into item as integer, and then I'm going to say plus, I'm going to add 45 into it. Okay. And else I'm going to do is that I'm not going to do anything. I'm just going to say uh, null, and I'm going to take value from this. So I'm going to vol res into this, and then lastly we will be printing the resource. Okay. So now we have this function, and what we need to do is that we need to pass some values. I'm going to pass the name into it. I'm going to print type. I'm going to pass a random number. Let's add 5 so that we know that 5 plus 5 is 45 is equals to 50. And one value that I want to add is perhaps print type as maybe L, long value, a long value. That's what I added. Okay, now let's just run this and see what happens. So you can see what happened is that when it was a string, this is operator helped me identify if it's a string. And then over here, what I did is I casted that value because at this specific point, that item was any, its type was any, it can be anything. Oh, so I changed this its type into a string and added as, wow. Another thing that I did was changed its type into an int, and then I added some stuff into it, and you can see that it worked perfectly. But there is one more way that we can use with this nullability that we basically discussing, and that is that rather than having this some stuff like this, what we can do is that I'm gonna implement something else. Okay, what I'm gonna do is that I'm gonna say that item as along with the question mark and say string. Okay, so if it's something like this, I'm gonna set it as this and say if it's not null, what I'm gonna do, I'm gonna print ln, and then over here I'm gonna use it plus wow. Okay, and we can do the same thing for integer as well. And then over here, rather than having int, I'm going to add 45 into this. And last one is basically, since it's print type, we won't be printing anything. And now let me just run this again. And now over here again, when I printed this, you saw that it did the similar job, but this time I didn't, I added the when operator. And there will be cases where you have specific value and you want to compare it just one data type. It's not something that you'll be comparing with multiple data types. So you want to see if it's a specific type of object, if it's a specific type of class that you are accessing. If it's there, fine, else you can ignore that. So this is how you can safe cast. This is basically called as safe casting, where we are saying that if it is a string, fine, else it will return a null to us. And if it's a in this case, we'll basically handle it this way. Now, there's one more thing I think we should cover before I end up this video, and that is going to be with, like a nested kind of nullability. So let's say we have a class and it's called as person. It has a var name as string, you know, and the string like something like this. Okay, so this is a class that we have, and now what I'm gonna do is that I'm gonna use this for wall p is equals to person, and I'm gonna pass that name that I've created over here. Now what I'm gonna do is that I'm gonna print that. So if I try p dot name dot length, the system is going to, what's gonna do, it's gonna complain that you cannot access the value because you're not using the type safety. And no, since I know that this person is basically non-null, let me just make it nullable as well to make a little bit more of understanding. So what I'm gonna do is that I'm gonna use this call safety for this one. That if it's a call safe, fine. If it's fine, else what we can do is that we can print a zero. So now if I run this, you can see that what it did is that first it checked if p is null, and if it's null, then you access the name. And then it checked if the name is null, and if it's the name is not null, sorry, yeah, if the name is not null, then you access the length. If it's the name is null, then you can go over here and check this one as well. Now let's say I want to change that and this one as well. So basically what I did is basically I switched that to this. And now if I run this, you will see that it won't be a problem and it will print it. But if we remove this one, what happens if we remove this one? You will see that it will complain. And why it's complaining? Because now the name is not, like, it's, we know that it's not null, but why does it complain over here? The reason it's complaining over here is that this p, because this person is nullable, there are chances that this p will be null, and if the p is null, then even if the internal value is non-nullable, it doesn't matter because the parent class or the parent variable that's basically accessing this is null. And that is why it will still be complaining and it still will be asking you to have, that question mark added into this. So basically, that's how this whole thing work. And I hope it made sense. And let me know if you have any other questions in the comment box, and I'll try to explain them. So, thank you so much for watching the video, and I'll see you in the next video. Till then, happy coding. Bye.
Thank you so much for watching the video. If you found this tutorial helpful, don't forget to like, subscribe, and press the bell icon so you don't forget any update. If you got any question, you can join my Discord server. The link is in the description. Also, for quick updates and tips, you can follow me on Instagram. Until next time, keep learning, keep developing. Bye.